Everyone, welcome back to Array series. Hope you are doing good. This is Mahesh. In this video, we are solving LeetCode problem number 15, which is three-sum problem. Okay, so let us look into the statement of this problem. So given an integer array nums, return all the triplets nums of I, nums of j, nums of k such that I is not equal to j and I is also not equal to k and j is not equal to k, and nums of I plus nums of j plus nums of k will give us 0. Notice that the solution set must not contain duplicate triplets. So this is a very important point, and they have given few examples. And if you see the constraints, the length of nums array ranges between 3 and 3000. So there will be at least one, not one triplet, but at least 3 numbers will be there in the nums array. Then the the value in array can ranges between minus 10 raised to 5 and 10 raised to 5. Okay, with that, let us switch to the editor and let us try to understand the problem. So now, if you see, they have given this particular nums array, correct, right? Now we need to find the triplets which will sum up to give us 0. So now if you see, there is this triplet which will adds up to give us 0. Say for example, minus 1 plus 0 plus 1 will result to give 0. So this is one triplet for us. Now again, if you see minus 1, 2 and minus 1. So minus 1 plus 2 minus 1 will result in 0. So this is one triplet, and this will combinedly give us another triplet. Now if you see, there is this combination 0, 1, minus 1, which will again give us result 0. But this is not, we should not consider this. Why? Because we have already considered minus 1, 0 and 1. So if you see, minus 1, 0, 1 is one triplet which we have already considered. And the other one, now what we are seeing is 0, 1, minus 1. But if you sort them, this will also become minus 1, 0, 1, which is already there. Correct, right? So we should not consider this duplicate. That's what the problem statement says. And also they have given I should not be equal to j and I should not be equal to k and j should not be equal to k. What does it mean? So now if you see in the array, if you take 2 comma 2 comma minus 4, so we are repeating 2 twice, correct, right? And this will also give us 0, but this is not the correct triplet, because we should not repeat any number. That is what is the problem statement says. So we will have to take all the unique triplets, something like this, minus 1, 0, 1, and the other one is minus 1, 2, and we will have to return this answer. So that is what is the problem statement says. Okay, so with that, we have also seen the constraints. Maybe what you can do, you can pause for a second and you can think for any possible solution, and then you can come back and watch this video. So now let us try to understand what interviewer will be looking at us after giving this problem. So basically he wants us to solve this particular problem in O of n square time complexity and O of 1 space complexity. Okay, so this is what he will be expecting from us. So with that, let us try to start with the brute force solution. So what is the extreme brute force solution for this one? So it clearly states, right? We will have to combine three numbers. Basically we will have to sum up three numbers, and which will result 0, that triplet we need to return. So before proceeding with the brute force solution, so there is a prerequisite for this particular problem, which is two-sum problem. So I highly recommend you go back to my video, which is a two-sum problem. So we will use the better and best solution from the two-sum problem to solve this particular 3-sum problem. So I will leave that link in the description. So now for the brute force solution, we will try all the possible combinations. So how to try all the possible ways? So basically what I will do, I will put 2 pointers, one here and another one here. Then what I will do, I will assume this is my first number and this is my second number. Then I will iterate over all the remaining numbers, basically one after other. Then I will sum these with these two numbers. And then I will check if it is equal to 0. Then I will consider that as my triplet. But before considering that triplet, I will basically sort, because we don't want the duplicate values, right? I will sort it, then I will add it to my triplet list if it is not there in the list. Okay, so now if this combination does not work, then what I will do, I will move this pointer to the next number. So now I will consider this as my first number, this as my second number, and my third number can be this or this or this. Then once this iteration is done, again I will move this to the next number. Then I will consider this as first number, second number, then this can be my third number or this can be my third number. So I will sum up and I will check if it is equivalent to 0. So once I process all these values for the second number, then what I will do, I will move my first number from here to here. Okay, so now I will move my second number from here. So now my first number will be this, second number will be this, and third number can be this, this or this. This way I will try to generate all the possible combinations. So it will be basically these three numbers first, then these two and this, okay, then these two and this, okay, and these two and this. So in the next iteration, these two and this, these two and this, these two and this one. Likewise, I will try all the possible combinations. So if I want to do that, basically I need this first pointer. Then I need this second pointer which points to second number. Then I need one more pointer which points to the remaining elements, which is basically our third number. So what I'm trying to say is basically we need 3 for loops here. So what I will do, I will use for loop, then I will use first variable as first, then it starts from 0, then it iterates until here. Why? Because if it reaches here, it can try adding with the remaining two numbers. But assume if it comes here, then it will be left with only two numbers. So there is no point in processing after this point. That's why I will start from 0 and I will move until n minus 3. So this is my first pointer. Then I will use my second pointer. So now if you see, our second pointer always starts after my first pointer, one place after my first pointer, correct, right? So my second pointer starts from first plus 1 and iterates until not n minus 1, this time it will be n minus 2. Why? Again the same reason like how we considered for the first pointer. If we are considering second pointer, it can iterate till this point. If it goes to this point, there won't be next number to process. That's why it is n minus 2. Next, I will take another for loop for my third number, which will start after my second number, because I cannot take first and second values. So it will be second plus 1 till n minus 1. Okay. So with this, now what I can do, I can sum these nums of first plus nums of second plus nums of third. Okay. Then after this, what I can do, I can check if my sum is equal to, if my sum is equivalent to 0. Then if it is the case, then I will add all these numbers to my triplet. We will see how we can do that in the code, but I will simply say triplet dot add of these values basically. Okay. So this is how, I mean, we use the extreme naive way to compute the all the possible triplets. So, and also one thing what we need here, after finding this sum, before adding these values to the triplet, what I will do, I will first sort these triplets. Why? Because I don't want to have the uh, duplicate triplets in the list. Okay, so with that, if we see the time complexity, since it takes 3 loops, it is of order NQ. Okay, and we use extra space, which is a set to check whether our triplet already exists or no. So for that, maybe we will use some extra space, which will be like mostly order of n space complexity. Okay, with that, let us try to execute this and see. Let us take a variable int n, which will hold the length of nums array. Okay, after this, we need set of list of integers. Okay, basically integer. So this is our set which will contain the triplets basically. So I will say triplets equal to new hash set, new hash set. So now let us take for loop int first equal to 0, first less than n minus 2, first plus plus. Okay, this is first for loop. Then in the second for loop, I will take int second equal to, which starts from first plus 1. So it starts from like one index after the first index. So first plus 1. So second less than n minus 1. Then second plus plus. Then I will take another loop for int third. So I will copy this variable third. So third starts from second plus 1, then third less than n, third plus plus. Okay, so this should be for. So now what I will do, I will check if the sum of the values, basically nums of first plus nums of second plus nums of third, if it is equivalent to our target, which is 0, then we got our triplet. So now what I will do, I will say my triplet equal to, so basically triplet is list of integer. Okay, so triplet, and it will be arrays dot as list. So basically we have to say it as arrays dot as list, then we will have to pass all these numbers by separating them with commas. So I will do that. Let us expand this. So it will be comma, and this will also be comma. So this will create the triplet list. Now after this, we need to sort our triplet. So collection dot sort of triplet. So pass the triplet in that. So this is basically to make sure we don't store the duplicate values. Then once after this, simply add the triplet to the triplet set. So control V dot add of triplet. Okay, this way we add all the values to the triplet set. So triplet set will only store the unique values. Finally, we will have to return array list. Then we will have to pass the triplets. So basically this will be new array list of triplets. So hopefully that is it. So with that, let me minimize this and try to run and see. There is a small issue. Sorry, I missed semicolon. So with that, I will run again. it should be collections, my bad. So it gets accepted. Okay, now if I try to submit, it will give us TLE. Yeah, so it gives us TLE. So now we understood it takes order of n cube, correct, right? Why? Because we are using these three for loops here. So if I want to improve this, maybe from order of n cube to order of n square, then we should try to reduce any one for loop. So let us consider one combination of value which is -1, 0, 1. Okay, so I will take that value. -1 plus 0 plus 1 should give us target which is 0. Correct, right? This is what is the target we are looking for. Now, if I consider if I know one value, then for other two values, it will be like if I know this one, then for -1 plus 0, if I send this 1 towards right, it will be 0 minus 1, correct, right? So it is nothing but -1 equal to -1. So now what I'm trying to say, if I know this particular value, assume I know this value already, then the remaining two numbers will sum up to give me -1, correct, right? This is simple mathematics. So if three numbers give us 0, then if I want to take out one number, or if I know one number, the other two numbers will be 0 minus that one number. So that is nothing but -1 in this case. So if this is -1, it is the sum of two numbers. So now if you see, we reduced this problem to two-sum problem. Correct, right? That's why I recommended you to watch two-sum problem. So now if this gets reduced to two-sum problem, we can directly use the better and best solution from the two-sum problem to compute this three-sum problem. So now let us see how to do that. So what I will do, I will copy this array. Now assume I know first number, or let us assume this is our first number. -1 is our first number. This is our first number, correct, right? First number is -1. Now the target for two-sum becomes my main target is equal to 0. If one number is -1, then my target for two-sum becomes 0 minus of -1, correct, right? So this will be 1. So for now, if I know two numbers which will sum up to give 1, then these three are the triplets that are required. So now if you see 0 and 1, they will give us this particular sum. So we can easily say -1, 0, 1 are the required triplets, correct, right? So now we will use the better way or better approach from the two-sum problem, which uses hash set to solve this particular problem. But in two-sum problem, what we did, whenever we found any two values, we stopped there and we returned the indexes. But here that is not the case. We will have to scan all the available triplets. So we will do a small modification on the two-sum problem, and we will use that here. Now what I will do, I will take this hash set. Okay, now I will consider this number as my first number initially, then I will find the two-sum in the remaining numbers. Okay, then what I will do, I will move to next number, then in the remaining numbers I will try to find the two-sum solution. Okay, so that way what I will do, first I have considered my first, then my target for 2 sum becomes 1. Correct, right? Because first number is -1. So I will subtract that from 0. So my target becomes 1. So with that, now what I will do, I will start iterating from the next number. So I will take 0. My number is 0. So what we did in the two sum problem, we try to find the complement. So now the target for my two sum problem is 1. So if my number is 0, then my target is 1, then complement of 0 will be this target two sum, which is 1 minus 0, that is equal to 1. So now whatever this 1 we get, is it present in my hash set? No, right? It is not there. So what I will do, I will simply push my 0 to my hash set. Then what I will do, I will move to my next number. Now my next number will be 1. So my complement will be 1 minus 1. So which will give us 0. Now if you see 0, it is there in the hash set. So it means I found two numbers which result to give this target sum. Now I will take this particular number and my first number and whatever the value is there in my hash set to find the triplet. So now if you see, my first number will be -1 and my second number will be 0, which is the complement, and my third number will be the current processing. Okay, so now I got the triplets, but there is also one more condition they have mentioned. So if you see, again -1 appears somewhere in the list. So if -1 appears somewhere in the list, again we will get a duplicate record, right, which will be something like 0, 1 and -1. So if you sort that, it becomes -1, 0 and 1, which is same as this one. So I should not consider this. For this, what I will do, before processing this entire array, I will sort it. Okay, and I will skip the repeating numbers. Now assume we have this particular array, right? So now after sorting, what happens, it becomes -4, then -1, again -1, then 0, 1 and 2. Now if I process -1 once, then I will skip the next -1, because anyhow it is going to give the same combination. If you see, this will give -101 combination, and if you consider these three numbers, it will give -01. That's why I skip this one. So with that, let us try to write the pseudocode. So what I will do, basically first I will take a for loop. For first starts from 0, again it will travel till n minus 3. Why n minus 3? Because there is no point in considering the remaining numbers. Then after this, I will also need to skip the duplicate values. So if my first is greater than 0, because it should be greater than 0 to compare whether it is same as the previous number, then I will say nums of first if it is equivalent to nums of first minus 1. If it is same as the previous number, then I will simply continue. Okay, this is how we skip the duplicates. Then after that, what we need a hash set, right? So I will take set equal to new set or hash set based on the syntax. Okay, then now what I will do, I will start processing the elements from an element after this first index. So for I equal to first plus 1, then I less than n, I plus plus, then simply use the two sum problem solution here. So I will find the complement. So complement. So before finding this complement, we first need the two sum complement, correct, right? So that we can find here. So two sum or target for twosome, target twosome equal to, so 0 minus nums of first. Okay, so this will give us the target for twosome. Then now for the twosome, complement will be target twosome minus nums of I. So this will be our I. So I will get the complement. Now what I will do, if my set has complement, if my set has complement, then I found the triplet. So if that is the case, then what I need to do, I need to take out this triplet. We will see how to do that in the code. Then add that to our triplets list. Add it to triplets. Add it to triplets. Okay. After this, whatever the number is there, basically nums of I, you just need to put that into the asset. So set dot add of our nums of I. Okay, and here once after adding it to triplet, we also need to skip any duplicate numbers. We will see that skip duplicates. We will see that in the code. Then finally you return the triplets. Okay, so only thing what we need to find here is we have to effectively use the twosome solution. Otherwise, let us try to execute this and see. Let's expand this. Now instead of set, we need list of integers, which is triplets, and it will be basically our array list. This we use to store all the triplets. Then we use first for loop. Okay, so before everything, first what we need to do is we need to sort our nums array. So I will simply do arrays dot sort, then I will pass my nums array. Okay, so this will basically sort all the numbers in my nums array. Then n will give the length, then this triplets will store our list of triplets. Then this is our first number, which starts from 0 and goes till n minus 2. Okay, so now let us try to skip the duplicate values. So how we do, so if our first is greater than 0, and then we will have to check if nums of first, if it is equivalent to nums of first minus 1. Basically we will check its previous value. If both are same, then we will simply skip that. So we will need to continue. So this will basically skip duplicates. Okay, it will skip the duplicates. Once after that, we need target for twosome problem, right? So target twosome equal to basically 0 minus our nums of first. Okay, so this will be our target for our twosome. Then after this, we need a set. So basically set of integer set. This is to check if our value exists in the set. So if it exists, then we assume we get the triplet. So we will see that. So set equal to new hash set. Okay, then what we will do, we will use our for loop for int I equal to 0, I less than n, I plus plus. Basically we are using our twosome solution here. Okay, twosome solution using hash set. Okay, now what I will do, first I will find my complement. So my complement equal to basically target for our twosome problem minus nums of I. So this will be my complement. So once after this, what I will do, I will check if my set contains our complement. If it contains our complement, then we got the triplet. Correct, right? We got the triplet. Now, so now what I will do, I will take basically list of integer. So this will be our triplet equal to arrays dot as list. Then we will have to pass nums of first, this will be our first number, then complement is our second number, then nums of I will be our third number. Okay, so this will give us basically the triplet. Okay, once we get the triplet, then what we need to do, we need to add it to our triplets array list. So add of triplet. Okay, this way we add it, and after this we also need to skip the duplicates. So for that, how we do, we will basically check the second number with next number. So for that, while our I, because I points to the second number, plus 1, basically we need to check its next number. So if, while I plus 1 is less than n and nums of I is equivalent to nums of I plus 1, then until unless that, what we need to do, we need to increment I. Okay, so this way we will skip all the duplicate values. Then finally what we will do, we will have to add the value to the set. So set dot add nums of I. Okay, so basically this for loop is nothing but this is a two-sum solution, and here basically we add our triplet to the triplets list. So with this we simply return our triplets because it's a list of integer. So mostly this is it, and let us try to run. I will minimize this and see. There is one issue, it is containing one extra value. So let us see why it is happening. The issue is basically this for loop should not start from 0. So that is my bad, because always first number starts from 0, but the second number always should start from the next index of the first number. So it should be first plus 1. Okay, with that modification, let us try to run and see. So now it got accepted. I will submit my solution. Now if you see, our solution got submitted successfully. So if you see this better solution, what is the time complexity? If you see the time complexity, now we have reduced one for loop here. So the two sum will take only O of n time, and for the, on top of it, we are using one for loop here. Correct, right? There is one for loop, and this is our two sum problem basically. So it means it will be of order n square. So time complexity will be of order n square. What is the space complexity? So since we use extra space, which is our set data structure here, so we will take extra space to store the values. That is why it is of order. Okay, so this one our interviewer will not be happy with. So we need to improve this space complexity. So for sure, I mean, we know we can improve this using standard two-pointer technique. So let us try to use the two-pointer technique. So this solution, again, it is directly derived from the two-pointer two-sum problem with slight modification. So for that, what I will do, first I will copy the array. Let us, so to effectively use two-sum solution, first we will sort these numbers. So if I sort, -4 will be at the beginning, then -1, -1, then 0, then 1 and 2. So this is after sorting, Okay, now after sorting, let us consider this as our first number. So our first number will be -4. Okay, our two-sum target will become 0 minus of -4. So which means, which is 4. So if we find two numbers which sums up to give 4, then those are the two numbers that are intended, which formulates the triplet. So now to use the two-pointer technique, now we want to place two pointers. Okay, so this is our first number. We will assume this is our first number. Then we will try to process the remaining elements. So we will put two pointers. For that, I will take my left pointer. So basically this is 0th index, first, second, third, fourth and fifth. Now if you see, our left pointer is pointing at 1 and our right pointer is pointing at 5, okay, which is basically n minus 1. Now I will sum up the values at left and right pointer. So -1 plus 2. They sum up to give 1. Correct, right? But what is the target we are looking for? 4. So it means this 1 is less than 4. So I will increase my left pointer. It will point to -1 now. So -1, again it's the same number, right? So basically we will have to skip if the number is repeating. So that way, I mean, we will also skip the duplicate numbers, or if that combination does not exist, then there is no point in processing it again. So what I will do, I will move this to the next number. Okay. Now what I will do, I will take this 0, then I'll add it with 2. What is the total? Which is 2. Again, this is less than our target, which is 4. So I will increment my left pointer. Now this will be 1 plus 2. So again, which gives us 3. Again, 3 is less than 4. So I need to increment my left pointer. So which I do now. Now if you see, our left pointer and right pointer points at the same number. So we will have to stop. Now this is one iteration. Now it means we did not find any triplets. Now what I will do, I will move this pointer to the second number. Now again I will repeat the process. Okay, so my first number now will be this one -1, and this target will be 1. So this time my two-sum target becomes 1. So my left pointer now points at index 2 and right points at index 5. Maybe we will leave this. We can see that here only. Okay, so now if you see, now what is the value at this pointer? It is -1. What is the value at this pointer, which is 2? So -1 plus 2 sums up to give 1. So now if you see, we got the two-sum target. So it means this is our triplet, right? So -1 is our first number. Again -1, which is this one, is second number. This is my third number. So this and this number will combine to give us one triplet. So I will take -1, -1. Okay, so this is one combination. Now I won't stop here. I will still continue. Okay, so now what I will do, I will move this pointer here and I will decrement this pointer here. So why? Because we found the two-sum value, then we will decrement both left and right pointer. Now if you see, 0 plus 1, 0 plus 1, which sums up to give 1. So now again this one and this one are same, the two-sum target. So it means we found one more triplet. Now if you see, this number and this number, they combinedly give us one more triplet. So I will take those -1, 0 and 1. So we found another triplet. So likewise, I will continue for all the remaining numbers. So -1 I processed. Again I will skip -1 because this is already we have processed here. Then I will move to 0. Then I will process the remaining two elements. So likewise I will continue further and I will try to find all the possible triplets. So this one, if you see, we will do it in only two iterations. Basically one for the first number and the remaining iteration for the two sum. So our time complexity now boils down to O of n square. And since we are using two-pointer technique, our space complexity will be order of 1. So this is very important. So we have reduced the space by O of n to O of 1. That is the beauty of two-pointer technique. Okay. So with that, instead of looking into the pseudocode, let's dive. So I will expand this. Now we need this triplets, and we need this for loop. Then we will have to skip the values. Then I will remove all these things. Now what we need to do, we need to implement two pointer technique. Okay, so for that, now this basically I need this to some target, so I will remove only this part, and this will be two pointer technique now. So now we need left pointer which points at one index after our first index. So first plus 1. Okay, so there is some spelling mistake, I will copy paste better. So first plus 1, then our right pointer will point to n minus 1, basically the last number. Now I will use my while loop. While left is less than right, then what I will do, I will simply check the sum of all the numbers. So basically I will check, or I will first calculate the sum. So sum equal to nums of left plus nums of right. Okay, so now I use this sum. So basically I will check if my sum is equivalent to the target to sum, then I got the triplet. So now if that is the case, then triplet, then our list of integer triplet will be arrays dot as list. Then we will have to pass three numbers, basically nums of first, okay, then nums of left, then nums of right. Okay, these are the numbers. Then I will simply add my triplet to this triplets dot add of triplet. So I added my triplet. Now after this I will have to skip the duplicates. So basically skip duplicates. So while left is less than right, while left is less than right, this is the basic condition, and nums of left, if it is equivalent to nums of left plus 1, then simply increment our left pointer. Okay, I will duplicate the line. Now this base condition while left less than right remains same. Now I will have to check the right number. So if it is less than the previous number, so simply what I will do, I will say right minus minus, and finally I will say left plus plus if that is not the case, and right minus minus. This will make sure, I mean, we move the pointers towards each other. Then if that is not the case, then we will have to check if our sum is less than the target sum, then we need to increment the left pointer. So this is the exact solution that is derived from two-sum problem. So I highly recommend you go back and watch that video. Otherwise you might not understand few concepts here. So else right plus plus. Okay, so with this we are almost done. Okay, so hopefully there are no spelling mistakes. With this I will run and I will minimize this. So there is a small issue here, what it says. So there is again a small spelling mistake. So with this correction I will submit it. There is one more issue, what it says, index 6 out of bound. Nums of left, nums of right. So we should have reduced our right pointer. So my bad again. It got accepted and I will submit it. So our solution got submitted successfully. So this way we will effectively use two-sum problems optimal solution to solve our three-sum problem. That way we boil down the time complexity from O of n cube to O of n square. Okay, hope I was able to make you understand. If that is the case, please consider subscribing to my channel and also like the video, share this with your friends, and also comment in the video if you have understood this well. Thanks for watching the video.